Hi, this is Tony from Empower Me First College. So far, we saw examples of algebraic equations with additions, subtractions, multiplications, and division. For each equation we handled, we had only one of these operations at the time. Let's now look at an example of algebraic equation that has several operations. Let's say we have a cab driver who charges a base fee of $3.50, and in addition to that, he charges $3 per mile. So the moment the trip starts, the passenger already owes $3.50. And then on top of these $3.50, every mile costs $3. This means that we have two elements that constitute the price of the ride. These are the base fee as well as the $3 per mile. The base fee never changes. We don't need to substitute it by a letter. The $3 is also going to be a constant. It's always going to be $3 per mile, but the mile, the number of mile, the distance traveled is going to be a variable. So let's use D for distance, and we're also going to be interested in the price. The price is the other variable. Let's use P that will change with the distance. Looking at our first case, we have Wilfried that uses the service for 4 miles, and we want to know how much he pays. So price is what we are solving for. Put it alone on one side, and we said that regardless of the distance traveled, the $3.50 are always going to be charged. So this is our first constant, and to this we add $3 per mile. So 3 is our second constant, and what changes is the distance in mile. We use D. So this is the equation. P equals 3.5 plus 3D. So here we have two operations, an addition and a multiplication here. Applying this equation to Wilfried's case, we get price equals 3.50. We said that his distance was 4 miles, so D is 4, and we add the multiplication by 3, which is the price per mile in dollars. So 3 times 4 is 12. We add the $3.50, meaning that Wilfried pays $15.50 for his ride. And now let's look at Rebecca, who takes a cab to cover a distance of 6.5 miles. Using the same equation, the price she's going to pay for the ride is $3.50, to which we add her distance of 6.5 miles, that is multiplied by 3, the price in dollars. So we have $3.50, to which we add 3 times 6.5, which is 19.5. She will pay $22.50. Let's now look at an example for which we know the price of the ride and we are solving for the distance traveled. This is the equation we used before. We were looking for the price, and now we are solving for the distance, knowing the price. So D stands alone, and we have P, to which we subtract 3.5. We need to put brackets here. I will explain why in a minute. And we divide all this by 3. This is our new equation, and we are going to use it for the case of Luke, who spends $9.50 for his ride. So plugging the numbers into the equation, we get D equals the price of $9.50 minus 3.5, all this divided by 3. Our D equals, this is 6, that we divide by 3 to get a distance traveled of 2 miles. All right, so why do we need the brackets here? We need them because we are doing the subtraction before the division. Only the miles change with the distance. So only the miles need to be divided by 3. The $3.50 is paid only once per ride. In other words, we don't want the 3.5 to be divided. Looking at the other version of the equation, when we go from distance to price, we see that the 3.5 does not get multiplied. Now we are going from price to distance. Since we didn't multiply the 3.5 before, now we cannot divide it. Remember, it's the same equation going in the other direction, meaning every multiplication becomes a division, every addition becomes a subtraction, and so on. All right, this was Luke. Let's do another example real quick. Say we have Victoria who pays $17. So as we did with Luke, we go from price to distance. So we use this version here of the equation. Plugging the numbers, we get for $17, Victoria has traveled 4.5 miles. Here is a quick recap of what we did. With Rebecca and Wilfried, we went from miles to price using this equation, the same for both. And for Victoria and Luke, we went from price to miles and we used this equation.